rapidly urbanizing country like India, the transportation sector is growing phenomenally and the number of vehicles on Indian roads is increasing by more than 7% per annum. During the last 50 years, from 1951 to 2001, the number of vehicles has increased by almost 143 times. This has led to overcrowded roads and a great deal of air and noise pollution. The transportation sector contributes as much as 65% of the total pollution in urban areas. There was a need, therefore, for generating a basic database as well as a rational analytical approach to predict the behavior of deterioration due to vehicular traffic on urban roads and intersections. The All India Council for Technical Education decided to conduct such a study in 5 important North Indian urban areas. A technical team was identified and formed with the mutual consent of 5 institutions, namely the Malviya National Institute of Technology, Jaipur, the Motilal Nehru National Institute of Technology, Allahabad, the Punjab Engineering College, Chandigarh, the Institute of Engineering and Technology, Lucknow, and IIT Roorkee, and a project called the Nationally Coordinated Project on Urban Transport Environment Interaction was sanctioned by the All India Council for Technical Education. The project was coordinated by the Centre of Transportation Engineering in the Civil Engineering Department of IIT Roorkee. The 5 cities selected for the study were different in nature and character in terms of traffic and land use. Delhi, a mega city, Chandigarh, a newly planned city, Lucknow, a historic city, Jaipur, a heritage city, and Allahabad, an ancient religious city. These cities are representative in their respective region from the point of view of vehicular traffic.
My heartiest congratulations to IIT Roorkee, the principal nodal institution under this nationally coordinated project, particularly the principal coordinators Dr. Jain and Dr. Parida, who along with the other 4 institutions, namely MNIT Allahabad, MNIT Jaipur, PEC Chandigarh and IIT Lucknow, have undertaken this study on the urban transport and environment interaction as one of the AICTE's nationally coordinated projects. AICTE is very happy that the results which this study has come up with will be of use to policymakers as well as to these different pollution control boards, associations, professional societies connected with traffic and pollution. We are very happy that this study has done modeling, it has done predictions, and the results are going to be useful to policymakers and other respective agencies.
The study had the following objectives: to create a database related to traffic, noise and air pollution for the above cities, a national and international interaction through research dissemination and the exchange of ideas, the development of measures for reduction of pollution from motor vehicles, evolving a societal and legal framework for the benefit of users and the nation, evolving national policies and regulatory laws for enactment, the development of a standard prediction model for air and noise pollution for India.
We were fortunate in IIT Roorkee that a nationally coordinated project on urban transport environment interaction was sanctioned by the All India Council for Technical Education, New Delhi. This was a 3-year project sanctioned during a period covering April 2001 to March 2004 and involved 5 institutions. The aim of this study was to develop relationships between transport system and the environmental pollution, both noise and the air. And as a result, models have been developed for predicting noise levels and the air pollutants generated out of the transportation systems in the urban areas. Understandably, the study was very extensive. It covered 5 cities, namely Delhi, Jaipur, Allahabad, Chandigarh and Lucknow, having different historical background, traffic composition and the land use. And our Center for Transportation Engineering in the Department of Civil Engineering at IIT Roorkee organized a panel discussion on urban transport and environmental interaction on 27th of March 2004, in which a base paper was presented by Professor S.S. Jain, who is the chief coordinator of this project, and Dr. M. Parida, who coordinated this project. The participants were invited from Ministry of Road Transport and Highways, Government of India, CRRI, IRC, SIAM, WHO, RITES, Pollution Control Board, consultants and coordinating team members from other 4 institutions, and the faculty members from different departments of the institute. And I hope that this study would provide a very meaningful basis for evolving an optimal strategy between the balance in maintaining the environmental standards and the provision of transportation system structure. And we in Roorkee therefore feel very privileged to have had the opportunity of guiding this nationally coordinated project during the last 3 years, and I am sure that this project needs to be pursued vigorously for further follow-up action.
This effort in coordination and networking is unique to the educational institutions. The transport environment interaction primarily involves air pollution and noise pollution. R&D efforts involved in this project includes creation of database related to noise and air pollution, development of mathematical models for prediction of pollution as a function of various system and operating parameters, validation of models, and formulation of suitable strategies for pollution abatement. Under the able guidance of Professor S.S. Jain and his team, IIT Roorkee has been able to make substantial contribution to this very important national cause that directly touches the life of a common man.
The inputs of this project have been vital for strengthening laboratory infrastructure in the area of study of transportation environment interaction. Complete setup of instrument, computational software is currently available in the department for undertaking transport noise and pollution analysis. Faculty members involved in this project have developed competency to handle teaching of this subject also. The findings of this project can be used to develop curriculum at undergraduate and postgraduate levels on urban transport environment interaction. Research through MTech and PhD programs as well as doctoral programs are in progress. I am told that a number of papers have been published and MTech thesis completed.
In the country during last 50 years, metropolitan cities has been increased to 40, number of vehicles has been increased 240 times, and the road length has been increased only 10 times. Because of this, lot of imbalances has been created in urban areas, and we are facing lot of problems including the noise and air pollution. All India Council for Technical Education took a right decision to consider this project under its nationally coordinated project stream, and 5 academic institutions have been identified, and have received a very good cooperation from all the institutions, and all the institutions has worked for data collection, analysis, modeling and research applications. I am happy to note that with the financial support of the AICTE, all the 5 institutions have upgraded their infrastructure for study of noise and air pollution, as well as for the development of the human resource in this area.
To generate a database on noise and air pollution in all the 5 identified cities, certain locations were selected to represent the whole urban area in different land use zones like residential, commercial, silent zones and heavy traffic zones. Delhi, the capital of India, is one of the 4 mega cities of the country. It has more than 3 million motorized vehicles on its roads. This is more than the number of motorized vehicles of Mumbai, Kolkata and Chennai put together. The Centre of Transportation Engineering in the Department of Civil Engineering, IIT Roorkee, conducted a transport-related pollution study in Delhi as per the defined land use criteria and developed separate models for different land uses based on the methodology of the Federal Highway Administration or the FHWA. A detailed statistical analysis was also carried out to validate the noise prediction models. The team recommended a noise prediction model for Delhi where the noise exceeds permissible limits at all locations. It was found that Delhi has concentrations of carbon monoxide, nitrogen oxides and suspended particulate matter exceeding the permissible limits, whereas the concentration of sulfur dioxide was well below the limit. The concentration of carbon monoxide exceeds the maximum permissible 1-hour concentration at most locations most of the time. The concentrations of oxides of nitrogen was found to be higher than the permissible limits of 80 micrograms per cubic meter. In Delhi, suspended particulate values far exceed the permissible limits of 200 micrograms per cubic meter. A good correlation was obtained between the observed and predicted values of carbon monoxide, indicating that the predicted values can be used for determining the observed concentration.
Field studies were carried out at 23 different locations in Delhi for this project. At each location, geometric details of road, traffic volume, speed, noise level, and air pollutant concentration such as carbon monoxide, hydrocarbon, SO2, NO2, and SPM have been observed. These data have been used for the development of noise model, where equivalent noise level is a function of vehicle composition, traffic volume, speed, the location where measurement has been done, effect of barrier, effect of gradient, and effect of plantation. Similarly, air pollution models, both finite line source and infinite line source models have been developed using the pollutant concentration database. It has been found that the finite line source model has been efficiently predicting carbon monoxide for Delhi. All these models have been used for predicting noise and air pollution under alternate traffic scenarios.
Vehicular emissions are a bigger hazard in urban areas. These emissions, they can be carcinogenic and they can adversely affect various vital organs of human body, including brain, liver, kidney, etc. The project on urban transport environmental interaction at the Center of Transportation Engineering at IIT Roorkee, funded by Aicte, involves 4 other technical engineering institutions in country to carry out such studies on environmental interaction emissions caused by such vehicles in urban cities.
Jaipur, a heritage city, represents a typical planned urban town of the region. The Malviya National Institute of Technology, Jaipur, carried out the studies here.
This project is of national importance and the faculty has the latest equipment for working on this project. They are trying to develop the model for air and noise pollution for the city of Jaipur. They have carried out studies at different locations in Jaipur, and our ME students and BTech students are also participating in this project. So it has been a very fruitful project for us, and I am sure the quality, as a result of this particular project, they will be able to develop a very good model, and as a result of this model, I am sure the quality of life will improve significantly.
Engineering Department MNIT is part of nationally coordinated research project on urban transport environment interaction funded by Aicte. In this project, we have identified Jaipur as one of the city for carrying out field monitoring data on noise and air pollution. And beside this, we have also carried out the traffic studies. For this, we have selected 8 locations on the basis of different land uses, and after analyzing the traffic and air pollution noise data, we have finalized the model.
This nationally coordinated project aims to correlate traffic with environment, and the special emphasis is on the modeling of air pollutants and noise. The idea is to find out the suitability of various available models like Line 4, GM, GFLSM, Corton and FHWA models that have been used world over under Indian conditions, and to modify them suitably if required. We will be able to generate certain models which would enable us to assess the pollution status of various Indian cities in a very quick manner.
The studies at Jaipur established that Jaipur had a majority of gasoline-driven vehicles. The air pollution from automobiles can be reduced by improving the quality of fuel or by using alternative fuel like CNG, LPG, and improving automobile mechanisms. Bringing the vehicle to Euro standards will also reduce the emissions considerably. Plantation on the median will reduce visual intrusion. The line graphs of daytime variations for oxides of nitrogen and sulfur dioxide were also prepared. The GM and GFLSM models have been applied to develop models for oxides of nitrogen and sulfur dioxide. Allahabad, an ancient city famous for the holy confluence of the river Ganga, Yamuna, and the invisible Saraswati, has a place of pride in Indian history and religion. A favorite place of scholars and kings, Allahabad was also the home of Pandit Jawaharlal Nehru and Motilal Nehru. The Motilal Nehru National Institute of Technology carried out the project studies here.
Allahabad is a city of considerable historical and cultural importance. The 3 national highways, including the important GT road, pass through the city, contributing to its economy. On the negative side, the associated heavy vehicular traffic also is a major source of environmental pollution. I am sure that the quantification and analysis of vehicular air and noise pollution through this research project will be of great value and will be helpful to the planners of the city in managing its urban transport.
During the project, 4 MTech theses have been completed. 1 PhD thesis has been in progress, and this year we are also giving 4 MTech theses. The developments resulting from this research project are also helpful in developing our laboratory works, training of laboratory staff, and infrastructure development for the laboratories, especially transportation engineering lab, environmental engineering lab, geotechnical engineering lab. The data that has been generated from this project, that will be of tremendous use to policy planners and in decision making for keeping a clean environment for the holy city of Allahabad.
In this research project, the excellent laboratory facilities of the department in the area of transportation and environmental engineering have been well utilized. I am sure that the findings of this research project will be of great help in planning various abatement measures for air and noise pollution due to urban traffic.
The traffic noise and air pollution study for the Allahabad city have been carried out at 3 locations in commercial zone, 2 locations in each silence and residential zone, and 1 location in heavy traffic zone. Air and noise pollution levels along with traffic and meteorological data have been collected at each of these locations. The data has been used for the development of air and noise pollution models for urban traffic. Noise pollution modeling was carried out by testing various available models such as FHW and Cotton models for their suitability in Indian conditions. For the gaseous pollutants such as SOx and NOx, GM and GFLSM models have been applied. GM, GFLSM and highway models were applied for modeling particulate matters such as SPM and RSPM.